Hey everyone, and welcome back. I think this is episode 4.5, um, and this will be a very quick video that just goes through um, a better explanation of exactly what we were doing. So basically, I'm going to be going back through. I'll just write this. So I'm just showing you that this formal definition that the formal definition I gave, the recursive definition of value, is in fact precisely truth tables that you've come to expect. So let's write over here the formula not P and not Q. Okay. And let's try to compute the value of this statement. Okay. So beginning with P and Q, the possible assignments of P and Q are both of them could be true. P could be true and Q could be false. I don't need to bunch this up so much. P could be true and Q could be false. P could be false and Q could be true, or P could be false and Q could be false, right? So you'll notice I'm literally drawing a truth table, but I'm gonna write out the truth table for this basically. But in doing so, I'm gonna explain precisely how this is in fact the definition of values, right? This is, remember, this thing, everything on the bottom here, down here, is going to represent the value of the above expression. And recall that the assignment for just a sentence symbol, the value of the sentence symbol, the value of the sentence composed of just that sentence symbol is merely the assignment of that. So now let's do not P, and let's have not Q. And now not P will have a value of true whenever P is false, and the sentence not P will have a value of false whenever P is true. And precisely the same applies to Q. And I might do a little line here to demonstrate that this on the left is the assignments of the variables. And now let's try the sentence not P and not Q. So recall from the definition of value that a sentence, if phi is of the form psi and pi, then not P and not Q, then not P and not Q, or rather if phi is of the form psi and pi, then phi will have the value true only when both psi and pi have the value of true. That's the definition of value. And so it's only in this case down here when both of the elements of the conjunction have a value of true that the entire expression has a value of true. And then finally, the negation will just flip and give the opposite value. So I did this for two reasons. One, okay, so clearly this is right. So when you're calculating, when you've learned, in the past, you've calculated the value based off of a truth table. What you've done is this. You've broken the big expression down into little tiny expressions, and sort of recursively computed the value of those and used it to build up to the value of the whole one. That's exactly the recursive definition we gave. So the recursive definition of value that we gave it aligns with the way we've been computing truth tables. So our formalization is valid. Secondly, this is exactly what we would want out of P or Q. Right? True, 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 false. Only false when both P and Q are false. So again, this is now, and like I said, it's not necessary to prove that this aligns with P or Q, because we've actually defined P or Q to be this expression on the right. But when we look at the values, when we use value and determine the value of the statement, we'll see that when we determine the value of the statement, we see that it has the value we expected it to have. So that's all. I know this was quick. Also, if you wanted to, like I said, if you wanted to prove, if you wanted to prove that and not are sufficient to express every connective, you would just find a formula that has every possible a formula only using ands and nots that has every possible valuing here. Recall I gave a definition of implies and equivalence, and you can also do this. You can build up implies and equivalence to see that it has the connective values we'd expect. I think that's it. I know that was pretty short. That's all I wanted to say for this one. Next video, like I said, we'll be getting into proof systems, so that should be pretty interesting. All right. Well, thanks for watching. I'll see you guys next time.